Hello and welcome to my neural networks project. Jumping right into it, we have our type map data, which were defined in the first two projects, which help us with the handling of the data. So we go into our neural network pipeline. Again, that data is prepared right here, much the same as the first two. Jumping into the cross-validation method, which we'll use as a jumping off point to talk about the neural network implementation. We see here we're splitting the data, and then we're creating our different preparing our neural networks, and then we have our candidate learning rates all right here for the hyperparameter tuning. And so we split the data, and then we're using it to create the neural network. So we go here, we create the neural network right here inside of our neural network.java file. So for classification functions, we initiate a linear classification. We initialize that, and we initialize that by creating an input layer. And so this input layer creates a node for each individual input, nominal data, and everything. And then we create an output layer here. Notice that we had the softmax activation function right there. So we create an output layer. And so for classification functions, classification problems, we create an output node per class, but for regression, we only do one. Jumping into data structures, we have our layers right here, which are array lists of nodes. To group up the nodes in each layer, use activation function as well as define left and right layers is a great way for collecting everything and making sure that we can apply activation functions. What you see right here is a softmax. So you see here we have the exponent in the numerator and then the summation of the exponents in the denominator. So jumping back to the output layer, we finish up here with creating all our output layers, and then we link them by iterating through each layer and then connecting them. You see here we have our node, which is an abstract, which serves as like our extension abstract for all the different outputs and input nodes, which define data, biases, and layers, as well as activation functions. And we also have output nodes, which are extensions of the nodes, which have this classifier, which is pretty useful. So jumping back, we define back connections and forward connections, and we link them by randomizing the weights, as you see right here for the connections. So jumping back, moving quickly here, so we're creating our neural network, and that's already created. So we have our linear network right there. Unfortunately, only that one, not the other two. So we go right here, and then we evaluate it by calculating misclassified, or also getting the mean absolute error, which you can see right there. So we then continue to our learning, which is done by gradient descent. So we jump into our learning.java function file over here for classification problems. We use cross entropy, and we also keep a trailing queue of cross entropy, so we can use that for evaluation and make sure that we're still improving our data. So going into it, we operate our linear classifier, which essentially just moves the data through the pipeline and calculates those node values. So we take that total cross entropy, we calculate it here using the math.log as you do cross entropy, and we sum it, and then we record it, and then we back propagate here to get those derivatives so we can do our gradient descent. So we begin by adjusting our biases here, then we calculate our derivative of for our classification of the cross entropy with respect to the bias. So we operate here, we do our classification, and then we use our class probability -1, class probability. These equations are in the report if you're interested, and then we sum the derivative of the cross entropy with respect to bias for each class. And then you see here and then we record that old bias, step size, new bias. So we go jump back up, and then we adjust the weights, and we do the same thing again, jumping into it, and you'll see that this is all defined in the report. So we see the old weight step size, and you can see that's actually happening here. DC, this is the derivative of the cross entropy with respect to the weight for the class 4.0. Actually, this is the right node. So this is the node that it's originating from. You can see here in that this is the slope, and then we have our old weight right here, 4.9, and then we have our new weight, and they're just slightly different because our alpha is 0.0025. So that is the crux of what is going on here. It is this very similar thing for regression problems, except instead of using cross entropy, we use sum squared errors. Thank you.